Let me try to explain what derivative is as easy as possible. Okay, let's consider function f of x. Let me just plot a graph. And it's gonna look something like this, right? So here's our x point, and here's x plus delta x. This is our delta x, and this small part over here is our delta y. Okay, let me just put this graph aside so I could do some algebra here. So we know there's a formula to find the average rate of change is delta y over delta x. So for delta x, we just have to subtract x from x plus delta x. So let's write it down, x plus delta x minus x on the bottom. And on top, we just have to input it into f of x, right? So it's going to be f x plus delta x minus fx. Looking better. Here we just cancel out our x's. And in denominator, we just have delta x. On top, we leave it as it is, right? So we know that delta x is the distance between the first and second point. But what if our distance was 0? How can we do this? It might seem impossible because you cannot divide by 0, but let me show you. If you're going to take a limit of delta x approaching 0, it's going to work this way. All right, there we go. We have this over here. And let's try to see it on practice. If our f of x equals x squared, right? Let's try to input it in this formula over here. We just have to input x plus delta x squared over here minus x squared. And we keep delta x on the bottom. We just have to open parentheses over here, which is going to be x squared plus 2x delta x plus delta x squared minus x squared. And delta x on the bottom, we can cancel out x squareds on top. Okay, and our second step is to factor out delta x. So we're going to have 2x plus delta x over here in parentheses. We have delta x in denominator. They cancel each other out. And it results into limit of delta x approaching 0 to x plus delta x. So when delta x is approaching 0, it's just going to be 0. Therefore, it's going to be 2x. And that's how you find the derivative of every function you want.